Hi everyone, this is Sonu Satyadas. Today I'm going to talk about the new Microsoft Azure service for running containers in the cloud platform, that is the new Azure Container App service. So if you see, the Container App service is currently in preview. That means it is not available for production environment. There can be changes when it comes into Gen GA. That means when it comes to into production. So currently, this is a new service that helps us to run the Docker containerized applications on the Azure platform. So primarily, this is used to deploy one or more containerized applications in a serverless platform. Means if you have a microservice, you want to deploy multiple containerized applications in the Azure platform, then we can use the container apps. So this is one of the best service for deploying your API endpoints, event-driven applications, or you need to execute some kind of background processing task, or for deploying microservices, you can use the container apps. This is coming with the Dapper support. Means if you are creating microservices with Dapper, then you can use the container apps as it provides the built-in support for the Dapper platform or Dapper environment. You can easily scale the applications based on the HTTP traffic, or based on a queue, or you can also use the Kubernetes event-driven autoscaler supported parameters that directly supported here. So while configuring the scaling for your containers, you can choose either the HTTP traffic, or you can choose the queues, or you can also select any of the supported KEDA scalar parameters. So when it comes to the features, we can run multiple containers, multiple versions of the same application. We can scale the container to running inside the container apps based on different parameters, including the KDA supported scalar parameters. It supports the HTTP ingress. So if you want, you can deploy your application and make it accessible only within a virtual network, or you can add one HTTP ingress that helps you to access your application publicly from anywhere. You can split the traffic across multiple versions of your application. That means you can deploy multiple revisions of your application, and you can split your traffic. Like if I have version 1.2, then I can say, okay, 20% of my traffic should go to that, and version 2.0, and 80% of the traffic should go to that. So I can split the incoming traffic across multiple versions of this application. Use internal ingress and service discovery for securing the internal only endpoints. Means if you want to deploy your application that is accessible only within this particular private network, you can make it internal only, and it provides service discovery for your applications. Also, I said there is a Dapper support for building the microservices. It's a framework or platform for building microservices. So you can use the Dapper platform or framework for building this microservices, and it provides built-in support for Dapper. This support public and private container registries. Means if you want, you can deploy your containers from the private container registry, such as Azure Container Registry, that is Azure, or you can use any other public container registry like the Docker uh, Hub or any other public container registry which can be of the Azure CLI extension and the ARM template support. You can use extension CLI extensions to create and deploy the container apps since it is in public preview. So you need to use the extension to create and deploy your container apps. And you can also see the ARM template support is available. VNet integration helps you to deploy your container apps in a private virtual network so that you can make sure that your application is accessible only from the virtual network. But if you want, you can make it accessible from outside by using an HTTP public ingress. Secrets management is supported, means if you have some sensitive data like passwords, connection string, or anything that needs to be used inside your application, you can store these secrets in the container apps, and that can be later passed into the application using templates or maybe the environment variables. The application logs with log analytics. You can collect the logs which is generated by the application in log analytics, and later you can analyze that to identify the performance, the execution nature of your application. For creating the container apps using the CLI, the first thing that you need to do is to add an extension for the container app because it is in public preview. You have to add this extension or container app to the Azure CLI. Then you also need to register the Microsoft.app namespace to your subscription because it's now in the stage of moving this apps from the Microsoft.web namespace to Microsoft.app namespace. So you need to register this Microsoft.app namespace in your subscription. Later, you can create your um, container apps where you will get you need to first go and create an environment. So you can create an environment, something similar to the app service plan, where you can deploy multiple container apps inside an environment. So environment is just acting like a logical container for your container apps. So you need to go and create a container app inside your resource group. So for that you can use the AZ container app environment create command that is going to create a container app environment. Then inside the container app you can deploy the container app using the AZ container app create command. There you need to specify the name, resource group, and the container app environment name. What is the Docker image that you are planning to deploy for this container app? And you can specify the target port number for connecting to your application. And also you can specify what kind of ingress need to be deployed. So you can say external for make it publicly accessible. So as we discussed while creating the container apps, the first step is to create an environment. So what is an environment? It's simply an isolation boundary where you can deploy one or more container apps. Container apps runs in the same environments, are deployed in the same virtual network, and they write the logs in the same log analytics workspace. So that means they share the same virtual network, they write the logs into the same log analytics workspace. Once the container apps environment is created, you are now allowed to deploy your containers inside the container app. So you can create a container app which deploys one or more containers inside the container apps environment. So containers in the container apps can use any language or framework or environment. It can be a .NET application, Java application, or it can be a Node.js application. But currently it supports only the Linux-based images, so you can create and deploy only the Linux application, Linux Docker images into the container apps. And you can deploy it from any public or private registry. So you can say when you deploy a container app, it is creating a revision of your container app. So it is by default creates a default revision when you deploy the first container, and later when you make changes inside your configurations, maybe you are changing the settings of your container, or maybe you are changing the version of your container application image, or you are changing the configuration of your container app or containers, like you can change the allocated compute like the CPU and RAM. So any configuration changes that you make to the container app is going to create a new revision automatically. So that means when the configuration changes inside the container app, it creates a new revision of your. So currently it supports only HTTP and HTTPS protocols, and that means you can connect using port number 80 or 443. So when you deploy your container apps, it is deployed means it is deploying these containers inside the pods. The pods is the concept that we use in Kubernetes, and behind the scene, the container apps using the Kubernetes deployment or Kubernetes environment for deploying these containers. So that means any container that you deploy in as part of this container apps runs as pods. So every pod may contain one or more containers uh, inside this pod. So containers in a pod share the same hard disk, network resources, and experience the same application lifecycle. So typically when we deploy the applications in the pod, so we deploy a single container or single container app inside this pod. But some cases we also deploy multiple containers as part of the same pod. Like if I have a sidecar application for logging or monitoring, or maybe for so event handling or some kind of processing, I can run some kind of sidecar applications as part of the main application. In such cases, we can run multiple containers in a single pod as well. So these multiple containers that runs inside a single pod will share the same storage, same network, and the same application lifecycle. So you can define more than one container in a template configurations containers array. That means if you are deploying it using the ARM template, inside this templates containers array configuration, you can specify the list of containers that you want to deploy as part of the same code. So, but when you deploy this multiple containers inside this code, you need to understand there are some limitations that containers that require root access cannot run inside this container apps, because sometimes we need to run some application with a root access privilege or administrator access privilege. So such containers we cannot run inside this container apps, and only Linux images you can run inside this container. So currently it is supporting only the Linux-based containers. So when you specify the container size, means when you deploy a new container, you can specify the CPU and memory that need to be allocated to the containers. So you can specify any of this combination. So if you are specifying the CPU as 0.25, then you can specify the memory as 0.5. So you need to specify this combination. Cannot give a wrong configuration or wrong combination for CPU and memory. Whenever you assign one CPU, then you have to specify the memory as 2 GB. So revisions typically deploys whenever you make changes inside your application. So when the first revision is automatically created, whenever you deploy the application for the first time. So when you deploy your application or when you create your container app, it automatically creates one revision, and new revisions will be automatically created when you make the configuration changes. And these revisions are immutable. That means you cannot delete or modify those revisions, but you can create new revisions based on this previous revisions. So the revisions mode can be a multiple or single. That means if you want to run only one revision at a time, suppose if I have deployed my application's version 1.0 and I want only the version 1.0 to run at a time, then I can set the revision mode as single. But if I'm deploying two different versions of this application, suppose if I have a version 1.0 and version 1.5, but I want the version 1.0 should get 25% of the traffic, and the remaining 75% of the traffic should go to the version 1.5. In such cases, I can deploy both the revisions, or I can run both the revisions and split the traffic across multiple revisions. In that case, I need to set the revision mode as multiple. In that, the application will be serving the request either by using the revision or revision 2 based on the traffic that you are allowing. So the traffic directions, as I have mentioned, you can set the multiple revision mode, and you can say, okay, 80% of my traffic should go to one revision and the remaining 20% should go to another revision. So this is a better solution for doing the A/B testing or blue-green deployment. You can use this multiple revision mode approach in container apps. So we can configure the traffic splitting inside your configuration in such a way that the revision name need to be specified and the weight number you have to specify in percentage, but make sure that the total value of this weight or the percentage is 100. So it should not exceed 100, or it should not be less than 100. So you have to make sure that whatever revisions you are deploying, the total value of this weight or this percentage for traffic splitting should be 100. So when you run this microservices with container apps, you can deploy multiple versions of your application, multiple applications, multiple APIs within the same container app environment. So suppose if I want to run a microservices application which has multiple API services, I can use a single container apps environment, and inside a single container app environment, I can deploy my first container app, which can be a microservice 1, and another container app within the same environment that can be the service 2. So the container apps providing the scaling of your application, independent scaling of your services. You can deploy multiple versions of this application, and you can easily upgrade the versions, or you can also upgrade the configuration of your applications and the infrastructure independently in a container app. So it provides built-in service discovery for the applications, and it provides the native Dapper integration. So if you have created your microservice using the Dapper, then you can make use of this Dapper environment that is provided by the container apps. Now let's see how we can create a container app in the Azure portal. So here, for that, first I'm going to create a resource group, and inside the resource group I'm going to create a container registry where I'm going to store my Docker images. So first I'm going to my resource groups and then create a new resource group. So I can give the name of this resource group as container groups, and I'm going to set this location as East US. We create that. Okay, so you can see my resource group is created. Inside this resource group, I'm going to create my container registry. So I'll just go to create and search for container registry. And I can specify the container registry name, location, and this queue. So here we can see my subscription, a resource group, and here I can specify the name of the container registry. So I'm going to give the name as BST containers. Yes, the BST containers is available. So I'm going to specify the location as again East US. So let me select East US, and I can specify this queue as standard. And for networking and the encryption, I can leave the default values as it is and create. This may take a couple of minutes to create this container registry. So you can see the deployment is in progress. We will see the container registry creation will complete in another couple of minutes. Yes, you can see the container registry is created here. And if you go to the repositories, you can see currently there is no repositories inside this container registry. And in the overview, you can see the login server name, SKU, and the provisioning state and other information like resource group, location, subscription, etc. So the first thing that you need to do first is enable the admin account for your uh, container registry. So for that, you can go to the access key section, and then inside this admin user, you can enable the switch that is going to enable the admin user for your container registry. After this admin user is enabled, now we can build our first container application using .NET. So I'm going to use .NET 6 for building my application. So I'm going to create an MVC application, .NET new MVC, and then I say container app UI. So this is my application. So I'm giving the container app UI as the name for my MVC application. It's been created. So let me move to this application folder and open that project in VS Code. So here, this is my application, and this application has a home controller. The home controller provides index and privacy actions. And in the index action, you will see a simple home page that is going to display the welcome message. So if I go back to my index, so here you can see a welcome message. So I'm just modifying this to welcome to container apps. So let me save this and run it locally to check whether it is working as expected. So let me say .NET build. I'm going to compile this and I can run this. So it's taking time for, yeah, it's done. So that .NET run command I'm going to use to run this locally. Yep, I can go and click on this link. Yeah, here is my application. So my application is running locally. So now I need to containerize this application. I have to dockerize this application and build this image and push that image to my uh, container registry. To containerize this application, I am going to create a Docker file inside this project, Docker file, and I need to write the set of commands to dockerize this. I have this commands already created. I'm just copying this commands. So this is going to use an .NET 6 SDK for building and publishing this application, and then uses one .NET ASP.NET Core runtime for running this container app UI application. So after this, I'm going to create one Docker ignore file. So inside this Docker ignore, I'm going to use the folders bin and obj, which I don't want to copy while dockerizing this image. So I can go and dockerize this application. So let me clear out the screen and say docker build -t and then give container app UI colon space dot. So I'm going to specify the uh, Docker image name as container app UI and the tag as latest, and the dot represents the path of this Docker file. So let's start building this Docker image. You can see the build process is going on. Once the build process is completed, I can see my Docker image in my local machine. Then I will run this in my local machine, check whether this Docker application is running as expected in my local machine. Yes, you can see the image has been created. You can now see the image which is created in my machine here. Yes, this is the image that I have created just now. Now I'm going to run this image locally. Docker run -p, that is 8080 minus rm st name, and then the name of this container app. Okay, it's running. So I can access my application on port number 8080. So let me open this browser, say localhost 80. Yes, I can see my application running locally on the Docker container. So what I can do is push this image to my uh, Azure Container Registry. For that, first I need to log in to my Azure Container Registry. So I have already logged into my Azure account, so I don't need to use the AZ login command. If you have not logged into the Azure account, you can use the AZ login command. But I have already logged into the Azure account, so I'm not using the AZ login command. Now I'm going to use AZR login command to log into my uh, Azure Container Registry. My container registry name is BST containers, so I can specify that name here. So let's see whether I'm able to log into the ACR. Yes, I have successfully logged in to the ACR. Now what I'm going to do is I am going to use the AZAZR build command, push the code to the ACR and build the image and push from the Azure itself. So let me type AZAZR build, then F1 registry, and the registry name is this hyphen image, and the image name is container app UI, and the dot for the location of my Docker file. So that is a source path, that is the current folder. So I'm using the dot. Let me press enter. You can see it's uploading the source code into the Azure, and then it build the image and push that image to the container registry. This may take a couple of minutes. Yes, it's built, and now it's start pushing this image to the ACR. Yeah, you can see the image has been pushed to the ACR. Let's go and verify that inside the ACR. So I'll go to my ACR and go to repositories, and there I can see container app UI is here, and the latest version of this image is pushed. Now let me go back and create a container app in my Azure subscription. For that, I'm going to create a resource, and then I'm going to search for the container app. So you'll see the container app which is in preview is listed. Let me select that and click on create. First of all, I need to go and select my subscription and resource group. So the resource group is selected as container group. And I can specify the name of the container app. So which I'm going to give as uh, container app UI. So this is my container app name, and you have to deploy every container app that you create inside a container app environment. So I don't have any container app environment, so I'm going to create a new container app environment by clicking on this create new. Here I can specify the name of the environment. So let me give the name as uh, my container app environment. Location I'm going to select as East US. So currently this is in preview. So only limited locations you can see here. So I'm selecting the East US and say create. If you want, you can enable the monitoring. Here you can see log analytics workspace will be automatically created, and you can also see the networking configuration. So if I want to use, I can use my own virtual network. For that, I need to select the yes and select the virtual network. And I need to have two subnets. One is for the control plane subnet and another one is for the app subnet. So the control plane subnet is used to deploy the Kubernetes control plane, and the app subnet is used to deploy our worker environments. That means the pods will be deployed on that. So we don't want to go and explicitly create the virtual network. So I'm going with the default option, that is the use your own network option. I'm selecting no, and let me go and create it. So here you can see my container app is selected. Let me go and click on the next. Here I can either start with a built-in image, a quick start image which is provided by Azure, but I have my registry available, so I can go and choose it from my ACR. But if you want, you can start with this quick start image. So what I'll do is I'll go ahead with this quick start image only. But if you want to start with your image which is already uploaded in ACR, you can go and select and deselect this option and specify the name of the container, and then specify the container registry. And from here, the list you can select your container registry, and from the registry you will be able to see the image and the image tag. So for the first time, I'm going to select the quick start image. So I'll go with this default image, that is a hello world container, and the default CPU and memory allocated is 0.25 CPU and 0.5 GB memory. And for the application ingress settings, you can see ingress is enabled. That means you can access this application from outside with HTTP port number 80. So I'll go and click on create. So this may take a couple of minutes to create the environment as well as the container app. As you can see, the deployment is completed. So let me go to the container app instance. So here you can see the container app is created. And here is the application URL through which I can access my application. So I can click on this URL. Yes, you can see the application is running on Azure. Now, if you see in the application configuration section, you will see an option called revision management, and below you can also see the containers. So if you go to the containers, you will be able to see the containers that is running inside your container app UI container app. So here you can see currently we have this simple hello world container is running, and this is the configuration for the currently running container. And inside the environment variables, if you have any environment variables, you can see that here. But currently we don't have anything. And if you want to make changes inside this configuration, you can click on this edit and deploy, and that will be creating a new revision. So we can also see the revision configurations under the revision management. If you go to revision management, you can see currently one revision. This is the default revision created, and this default revision is created and 100% traffic is going to this revision. But if you want, you can create a new revision and then deploy the new container. That means the containerized application that we have deployed into the ECR. So what I'm going to do, I'm going to create a new revision by clicking on this create a new revision. And here I can specify the name or suffix that you want to apply for your uh, uh, revision. So typically for the revisions, if you go back to the previous one, here for the revision, every revision name is something like your container app name, then double hyphen, and then there is a random string. So you can see here we have this revision. The revision name is the container app name and some random characters. But instead of this random characters, what you want to specify that you can provide as the suffix. So while creating a new revision, I am giving the name as suppose version 1, that is v1. So that is the suffix that I am providing. And I don't want to run this built-in Docker image. Instead of this, I'm deleting this. I'm going to add my own container from the ACR. So let me click on add, and from here I can specify the container name as app1, select container registry, and from here you can specify your container registry, select the image, and from here you can select a tag that is the latest which we have already, and I can allocate the CPU and memory. So I'm going to give 0.50 as the CPU, and the valid combination is 1 GB memory. So I don't have any environment variables, so I just click OK. So here I can see one container will be created inside this. Click on next if you want to configure the scaling. So if you want to configure the auto scaling for your container, you can configure the scaling rule here. So currently we have the image, that is one image, and I don't want to configure any auto scaling condition now. Let me go and create this. So this is going to create a new revision. But you can see currently this is the revision which is handling all 100% traffic. But you can see the revision is created, and if you click on this show inactive revisions, let me refresh. Yeah, so here you can see, I can see the new revision is created, and the traffic is now moving into this new revision. So you can see 100% traffic is going to the new revision that I have created. So if I go inside this revision, you can see the container configurations for that particular revision. So let me go and access this application. So this is the application URL. Let me refresh, and I can see this application is deployed. Now I want to update the application, and I want to update the version of this application in my ACR and deploy a new version of this application inside. So currently you can see I'm deploying version 1. So I want to deploy the version 2. So what I'm going to do is I'll open my project here, and inside this index page I'm making a small change in the message here. Say this is version 2.0 of Container App UI. So I'm going to save this, go back to the command prompt, and I need to push that image here. So I'll say AZACR build with the image, but I will specify the image version tag as 2.0. So you can see I'm pushing to the same registry, but this time I'm specifying the image name as Container App UI colon 2.0. So let me run this. You can see the image pull process is successfully completed. Now I can go back to the Azure portal and see whether the new image is pushed successfully or not. So I'll go to my registry, go to the repositories, select the Container App image, and you can see that version 2.0 is pushed. Now I want to deploy this new version of this application into the Container App UI. So what I'm going to do, I'll create a new revision. So click on create new revision, and I'll give the suffix as version 2, that is v2. And you can see currently this image which is running is the latest, but I want to delete and add the new image. So I'll just go and specify here as app 1 and just specify the image. So from here I'm selecting the Container App UI, and the version I'm selecting, that is the tag I'm selecting, is 2.0, and I can also specify the CPU and the memory. So let's go and create. So this is going to create a new revision. Yes, it's created the new revision, that is v2 is created, and 100% traffic is now going to this v2. So let me go to the browser and refresh this page, and you can see the version 2 is now visible. Now if I go back to my application, I can see at a time I will be able to run only one version of this application. Means one revision is handling all the requests. That means the 100% traffic goes to one revision. But I want to split the traffic between two versions, that is V1 and V2, that 50% of the traffic will goes to V1 and 50% of the traffic I need to forward to version 2. For that, First, I need to go and change the revision mode. So here you can see the revision mode is selected as single, which means only one revision will be active at a time. So I need to go and change the revision mode to multiple and say apply. So now once it is modified, you can see the traffic option is updatable, means you can go and change the uh, traffic values, the percentage values you can modify. So what I want to do is I want to make this version 1 and the version 2 active. So I'm selecting both, and here I'll specify 50 percentage for the version 2 and 50 percentage for the version 1. And let me save this. So the changes will be saved, and I can see when I run this application, some of my requests will go to the revision 1, that is V1, and the other requests can go to the revision V2. Yes, it is completed. Now let me go to the application in browser, and here I'm refreshing this. You can see this is the version 1. I can see when I refresh, some of the requests may go to the version 2. Here you can see now I'm able to access the version 2.0 also. So that means that traffic will be split between version 1 and the version 2 of my container app.